Every day we receive a lot of push notifications, from social media interactions to more delicate and private information as banking accounts, one-time passwords, or also purchases at online stores. This information travels from the application server to the application in the device, across multiple providers. Even though the communication between those providers is encrypted, mostly because it's HTTPS, the content of the push notification is mainly plain text. What it means that when a service sends a push notification with a one-time passcode, that OTP, that PIN, can be stored in any of a list of providers until it reaches your device. The same happens with purchase or account balance information. This opens the door to these third parties to analyze these kind of notifications. So this is quite insecure because this information it's not only visible for you, but it's visible also for a lot of services. Let me explain it with a little graph. So in this draw, you can see this application server, which is our application, which wants to send a push notification to an Android device, for example. For doing this, we use Firebase Cloud Messaging, which uses, of course, Google Cloud Messages. So this transport of information between my application server and Firebase, and from Firebase to Google Cloud, Mozilla, or Apple push notification services, that transport layer is encrypted. But the text, the content of the push notification is in plain text and can be read by any of these providers. There are a lot more about from this. So Project Jano is a very simple set of tools which includes an Android and an iOS library and a microservices written in Go, which allows you to create an encrypted push notification here in your server and decrypt the message only on your device. So the information is 100% secure. Moreover, that encrypted message is unique per user and per device. So you cannot decrypt that notification in another device even though you are the same user. It's completely secure and it provides end-to-end encryption to push notifications. So in this small example, I will show you the complete end-to-end notification encryption flow. And I will use an Android device, an emulator in my computer, and I will perform an HTTP request to the user service, which will receive the request of encrypting a push notification and will generate a payload encrypted and a signature for verifying the payload integrity. And then I will get all that information and put it into Firebase. I will do that manually, not using any kind of microservices or plugin or Firebase API or anything like that. It can be done automatically, and also it can be done with other service providers like OneSignal or Amazon, for example. So then, when Firebase gets this encrypted notification and send it to the device will capture the notification and will perform the necessary manipulation of that notification, which is decrypting it, in order to show the plain text message to the user. Because the final idea here is not to compromise the user experience, because we have added an extra layer of security. So I will stop talking. I will just go straight to the demonstration. So okay, I will send this notification with a body or text to say you have paid 1,000 euros on Amazon UK, and a payload. Yeah, this payload is just a JSON encoded object, stringified, which the application will receive and can do whatever it needs with that information, but this payload is not visible for the user while the body is visible in the notification. So, well, that was all it takes to create this. Just 22 milliseconds in my local environment. And I have the payload split into 3 fields, and the signature is split into 4 fields. This is because Firebase has a small restriction of the information that we can provide in the notification. So with this in mind, I will go into Firebase and I will create a notification. So in any notification you have a title, so this is the title, hello, and we have also text or body. These 2 fields are the one that you see when you open the push notification, and you can see in this preview. Okay, so as I have encoded body and the payload, when the device receives the notification, the body will replace this text here. Yeah? So that's a way of showing how we can send encrypted information and show the plain text to the user without compromising either security or user experience. So I will select the application, the test application, and also I will add the additional information because I need to go to get this payload and signature and load it into Firebase. So this is some sort of custom key value that I have assigned in order to send these payloads to the device. And now it goes the signature. Okay. One more key value and we are done. Okay. So now I have this encrypted push notification with the payload and the signature in Firebase, everything, and I will send this notification to my test device. So this is my test device right here. Okay, let's go. So here we have the push notifications. We will expect to see title and hello, but we see title and you have paid €1,000 at Amazon UK. While this part was an encrypted one. So we successfully sent information, which in this case is visible, with end-to-end encryptions to a device. Apart from this, the application have received additional information, which in this case is related to this purchase, which is the type of the operation, amount, the currency, and all that stuff, which it was just for test. But the most important part is that we can send encrypted notifications with very important information, like for example one-time password or also known as OTP. So this is so simple to do. It doesn't require an extra export. It's just basic end-to-end encryption and it's working.